Hello.
Yes.
Yeah, good afternoon.
Yeah.
Your description has explained me that you are into that DLP protection thing.
That is one of the controls I suggested, yes.
Okay. So I think that the kind of solutions you are having that train the employees and all,
Yeah.
it is like holding the raging bull by its tail.
Yeah.
If you develop instead you can develop an app like WhatsApp. How WhatsApp gets coded with the SIM card. That kind of app for the computer. Wherein they won't boot unless the card is there. If you can if you can hold the bull by its horn, then the entire system can work according to what the card and the card holder, and there will be some kind of belief. Vishwas bolte na jo. You have to keep that.
See, but what happens is that this is one level of control. That's why the DLP systems like DLP. Again, to clarify, I am not selling a DLP. We are a consulting company, totally neutral. So I am not trying to put a DLP solution.
Like that to control the booting of the computer. If the computer won't start only unless that app is there or the card is there, then if you control like that, then every browser or the downloading or copying, everything will be like authenticated. With the card holder, it can ask. If we can develop a software like that WhatsApp, then we can really hold this into your hands, and then there will be the leakage will come down to 80%, 20% leakage.
See, what happens is that that's a good point, but what happens with this is that primarily you're looking at the authentication of the person. Now let's assume I am one of the users of this system that you thought of. There are such systems in the market, and I have intentionally or I have privileged access to some data. Okay, I'm supposed to be looking at a balance sheet, or I'm supposed to be receiving some quotes from a client, or I'm supposed to be sending out a proposal. Just or look at some market stuff at the BSc. Now, using my privileged position within the organization, if I intentionally send it out, those systems won't work. That's where a DLP comes into place, where the mapping has been done, and they know who's supposed to be doing what. And lastly, what happens is that she's waving, yeah, hi. I'm done. Okay. Okay. The second part is that even if you have, it could be even unintentional. So, for example, my name is Narendra Sahu. Okay, so let's assume Mr. Jadhav is sending me a mail containing some, just as an example. Looking at me with the side of his eyes or something. So okay, so Mr. Jadhav is sending me an email, and my name is Narendra Sahu. There could be some Narendra Kumar somewhere else, and he is a busy person, and by mistake, he selects Narendra Kumar instead of Narendra Sahu. Happens, many people sitting over, you would say, yeah, I can see nodding heads. All those risks, now that is an unintentional disclosure of data, which happens in companies. And at such a level, a network level DLP, a system level DLP is something that can control such oversights, whether it is intentional or otherwise. That's where now in all these things also remember,
the operations of the system becomes cumbersome.
Not really. It depends. See, because what happens is that people put the DLP into discovery mode and then forget about it, and that's not how a DLP is supposed to work. Anyway, you've been a great audience. Thank you so much. I'll be outside in case you have any queries. Thank you. And please drop your feedback sheet. I would appreciate that. Thanks again.
Thank you, sir. Hired by Mr. Anand, Chief Executive Officer of Gramna. Before that, there are a few announcements to be made. The first announcement would be made by Sir.
Good afternoon, everyone. Again, I know all of you have seen me yesterday, but yeah, it's a double take. Yes, Contact Singapore is holding a parallel session again. For those of you, I understand, and I know I've seen a couple who have not attended yesterday's session. Please feel free to proceed upstairs. We're having another session today. Yep, right now. Thank you so much. Thank you.
Thank you, sir. The second announcement is related to the certificates. The certificates will be available at the counter after 4 p.m. I would request Anand sir to come and take over the session.
Objections that we hear when we say, look, there's so much stuff that you can do with data. We invariably encounter a series of objections that, no, we can't quite do this because of X. And what I'm going to be talking about is those objections that we often hear and why they are not necessarily true, or at least no longer valid these days. By and large, the objections that we get are around three areas: around the data side, around the analysis side, and around the visualization side. Let's start with the visuals. One of the most common comments that we get is, look, visuals are fine, but I want to be able to drill into the raw data. I don't want a static picture. I don't want to just be able to see the result. I want to be able to play around with it and interact with it. One of the earliest visualizations that we were playing around with was a representation of one-day international statistics. The question was basically this: who was the fastest strike rate? When we did the analysis, the player with the highest strike rate was a South African, and the player had a strike rate of 200%. He played one match, hit a 4, and got out. So yes, technically that's 200% strike rate, but that's not quite what you want, right? So what we did was build a small visual that looks at each person who's ever played one-day internationals in India and breaks it down based on the size. So the size is the number of runs they've scored. Tendulkar has scored the most runs in one-day internationals, followed by Ganguly and Dravid and so on. And the color represents the speed at which they were scoring. So Tendulkar was reasonably fast. Ganguly and Dravid and Azhar were much slower. Dhoni is faster than Tendulkar, and Sehwag is clearly much faster. And you know that you don't want Ravi Shastri and Sunil Gavaskar or Mohindra Amarnath playing in a one-day international with you. This is kind of known statistics, but what we also want is the ability to drill down into, for example, each one of their innings. So, which are the innings that Tendulkar played? So, this was where he scored 200, and that was at 137 strike rate. But he had some slower innings as well. So, here was one where he was striking only at 72, and he scored a century. But it wasn't a really fast century compared to the others. Or Mohindra Amarnath, Mohammad Azharuddin, for example. So, that was a pretty fast 153 that he scored against Zimbabwe in 98, and many of you probably remember that innings. But there are several other relatively slower innings, and one can go one level further into that and say what exactly happened during this match. So we look at the raw details and dive in and see the actual scorecard of Azharuddin actually scoring the 143 not out with 17 fours and a 6. And this is basically a picture that holds every single one-day international innings that India has ever played at one shot at multiple levels. And we can start looking for more things from this. So who plays well against Pakistan? So if I search for Pakistan, Azhar's got a pretty mixed performance against Pakistan, but Tendulkar is doing pretty well. Ganguly's had a mixed performance. Or who plays well at Sharjah? And it turns out that Dhoni has not even played at Sharjah. Yuvraj has had a pretty bad few innings and pretty bad performance there. Sehwag hasn't played at Sharjah. Tendulkar has had a pretty good performance at Sharjah. So what we are looking at is a way of looking at fairly large-scale data at multiple levels. And having seen this, the Ministry of Finance said, look, we want this. We want to be able to look at our budget performance this way. So specifically, we have accounts, we have ministries, we have major heads, we have minor heads, and we want to be able to drill down all the way down to the 150,000 account for every single transaction that we have. We do that. So here's some anonymized data around this. What we have here is the budget versus actuals for, taking some old data here, with the 2012-2013 budget, 2011-2012, 2010-2011. And here the color indicates to what extent the budget was underspent or overspent. The browner it is, the closer it is, the closer the actual spend is to the budget. They've almost exhausted the budget. Whereas the bluer it is, the less they've utilized the budget. And you can see very clearly that in 2012-2013, there was considerable underspend. Now, why is that? Let's drill in. Turns out that there was underspending practically all of the areas. In appropriation and interest, there was a budgeted amount of 68,000 crores, but only 33,000 crores, less than half of it was being spent. In Department of Fertilizers, that's probably the only place where they came to spending the full amount, 23,000 crores spent out of 26,000 crores. Cabinet was somewhere in between, 13,000 crores spent out of 18,000 crores. So where did the spend go? So it turns out in the police department, they were able to spend about 11,000 out of the 14,000 crores allocated, but in all the other cases, there was barely any spend. Where did this money go? So out here, a lot of it went into, for example, Border Security Force, Central Reserve Police, Industrial Security Force, etc. But in direction and administration and other expenditure, for instance, in all of these areas, there was considerable underspend. And then you can go down into what exactly happened in direction and administration and so on. So it's a myth that you can't really drill down all the way into raw data. I mean, this has always been there, and the capability to drill down in a visual fashion has always been there. It's no longer an objection that we find to be real. Another is that people say, look, we already use charts, we're already doing visualizations, so we've already exhausted the limits and the potential of what is possible, right? So what else is there? One such discussion we had with the media, and this was with CNN-IBN initially, and then with Times Now. For CNN-IBN, we were looking to cover the elections. They threw an interesting challenge. They said, look, what we want is for the anchor to be able to start answering questions live. We don't want a prepared script. The person calls up the anchor, and the person should be able to look at the visuals, see the results, infer them, and tell that to the audience right away. So we started putting these together on a 92-inch touch screen, and that's what you would have seen in the CNN-IBN election coverage as well, which was based on our software. And there were several interesting patterns that came out of this. One of the most powerful visuals was answering the question, how many people stand for elections where, how many candidates stood for election, how many people voted, etc. And that was on a map. So one of the questions that Bhupendra Chaubey got was, tell me, where did the largest number of people stand for elections? He started browsing through the visual. He said, okay, let's see, in Tamil Nadu in 1967 assembly elections, each of these circles represents one constituency. The size of the circle represents the number of people that stood for elections. So for example, in Dharmapuri, there were 5 candidates who stood for election, whereas in Perambalur, there were 10 candidates who stood for election in 1967. Now, the next year, things haven't changed much in terms of total number of candidates, but the next year there's a sudden spurt in number of candidates. The color here incidentally represents the party that won. In 1977, you see a sudden burst of maroon, that's ADMK coming in. And while, because of this extra party, there's also an extra candidate in practically all of the constituencies, and that leads to a certain spurt. But nothing really stands out until you get to 1984, when you have Madurantakam with 90 candidates standing for election, mostly independents. Well, that's a reasonable number, right? I mean, at 90 candidates, you no longer have a ballot sheet. You probably have a few sheets that you have to flip through to actually vote for the person. 1989, an overall spurt, but nothing really unusual. 1991, now we have something. Pallipet with 264 candidates and Avarakurichi with 249 candidates standing for election. So now you are no longer talking about sheets, you are talking about a mini booklet. You have to flip through to find your candidate. But all of this pales in comparison to the 1996 elections at Modakurichi, where 1,033 candidates stood for a single election. At this point, you need a book, not a ballot sheet. In fact, it's probably the telephone directory of Modakurichi. And this was a problem because if you look at the list of names that you have here, right? So, for instance, let me show you the names that it looks like. This is what it looked like. Parnisami, 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 Parnisami. I mean, if you're a Parnisami C, then how do you figure out which Parnisami C you are to vote for yourself? Right? Which seems to have caused some confusion because there were as many as 88 candidates who got exactly 0 votes, meaning they didn't even vote for themselves. They took all the trouble to stand for elections, they didn't bother voting. Either that or they couldn't find themselves in the voter rolls. No charts, we've barely scratched the surface of what is possible with visual representation. We're nowhere near the end, and there's a whole lot more to go with that. What about the next complaint that we hear, which is that all of this is fine, but this is in some other platform. We don't use this platform. We can't really integrate it. We, for example, use Excel, we use PowerPoint, whatever it is. Now, again, technology has gotten to the point where these are no longer constraints. For example, one of the visuals that we put together for an FMCG company was looking at the breakup of revenues. They said, we want to solve in PowerPoint, and we want the board to be able to query this in an interactive manner. So specifically what we did was, said, let's take your geographic breakup. The size of each of these arcs represents your total revenue of the region. And that's broken up by channels. So in the UK, how much are you selling to the direct channel, how much are you selling to the partners channel, how much are you selling to the stores channel, which is then further broken up by product. So what I can see is that in Japan, in the partners channel, one of the largest products, product 8, is not doing so well. The color here is a performance indicator, red being bad and green being good. So I can start investigating why is it that product 8 is not doing well. Click on that. I can see that it's only in Japan that product 8 is not doing well. In other cases, it's kind of doing okay. So why is that? Is that because Japan in general is doing bad? Click on Japan. And you see that Japan has a fairly mixed performance. It's not that just product 8 is doing bad. Several other products are doing bad, but several others are doing well too. And specifically, I can see that the direct channel is not doing well overall. So click on the direct channel. What are the performance of the direct channel and so on. And all of this merely in a PowerPoint presentation. Another question that people have is, look, we have to write reports around this. It's not enough just to have the visuals. We ultimately need the insight coming out in words, and that really can't be automated. Again, not true anymore. These days, the amount of automation that there is, you have templatized visuals, such as, let me show you one. This is a visualization of the market reaction to the budget. On the day of the budget, the stock markets react, going up or down for every single stock. The question is, how are they reacting? So if I pick a particular year, let's say 2007, and let's freeze it. the size of each box represents the total market capitalization of each of these sectors. So BFSI was the largest, oil and gas was the next largest, and so on. And the color represents how much they grew or shrank by. So red indicates that the sector shrank and green indicates that the sector grew. And you can see that there's only one sector that grew, which is right at the bottom, that's tobacco. Only tobacco benefited from the 2007 budget. In the 2008 budget, it was fairly mixed, but only tobacco benefited from the 2009 budget. If you look at the 2010 budget, only tobacco suffered from the 2010 budget. If you look at the 2011 budget, tobacco benefited unusually from the 2011 budget. Now, I don't know what's happening with tobacco. This is not an analysis of the tobacco industry. But what I want to point out is the annotation on the left, which changes by itself and is a pure text annotation that is computed in a way that you will be easily able to relate to. It says on 26 February 2010, the budget day, market grew by so many crores, about 1.2%. 20 sectors grew and only 2 shrank. This is the sector that grew the most, this grew the next, this shrank the most, this had the highest growth percentage, and so on. And the kind of text that you would normally put in any kind of descriptive report, which can be completely templatized. Today, reports are no longer being generated by people, at least at the cutting edge. Increasingly, the text around it as well is getting automated. So no, visuals are not about being able to put a pretty chart together. The visuals are really about helping people understand and consume data. And that, once people understand that, those objections start fading away. Another area that people look at is analysis and say, look, we are finding it difficult. And why is that? Well, the primary complaint that we hear is because we don't necessarily have the tools. Let's look at what kinds of tools it takes to actually analyze some data. One of the first pieces of engagement that we did at Gramner was looking at energy data, looking at how much electricity was being consumed by each person in a household in a state. And the reason for this was the Energy Commissioner said, we want to move towards automated readings. The union has considerable issues with that, and one of the reasons we are giving to the union is that automated meter readings will reduce the amount of fraud. They're saying, okay, show me where the fraud is. And now they say, we know that there are anecdotal pieces of evidence, but what we want is systematic evidence. Can you, given this data of every single meter reading for every single consumer in the state for the last 10 years, look at it and show where there is fraud? Okay, fine, let's do something very basic. Let's just find out how many people consume 0 units, 1 unit, 2 units, 3 units, and all the way up to 100, 200, 300, and so on. You'll see that it's approximately log normal. Very few people consume low units, very few people consume high units. And most of the people are in the middle, but there are spikes, and the biggest spikes are at 50, 100, 200, 300, which are precisely the slab boundaries. Now, given the metering system that they had, somebody who consumes 101 units will be billed at the next tariff slab, which means a significant increase. It's not an incremental billing, it's a slab-based billing, so which means that they end up paying much higher. And therefore, there's a strong economic incentive for me to stay at 100 as opposed to going to 101. Right? So, which was strong evidence that there's some amount of